Welcome to Study Loop.
We need the critical values for a confidence interval for the population standard deviation. So a confidence interval or sigma. Now we know the sample size is 31. We know the level of confidence is 0.95. So what kind of critical value do you use for confidence interval for sigma? Well, you use the chi-squared distribution. Chi-squared is the sum of some number of standard normal variables, each one squared. And the degrees of freedom tells you how many of those squared normal variables you add up. And in the confidence interval for sigma, it's n-1. So we have 30 degrees of freedom. So I'm going to draw a chi-squared distribution here. It's not symmetric, it has a long right tail. And when we say C is 95% confidence, that means that we have the middle 95% in our confidence interval and 5% in the tails. Now we can call the sum of the tails alpha, so here that's 5%, and each tail gets alpha over 2. So this is the bottom 2.5%, this is the top 2.5%. And we need the values to cut these off on this particular chi-squared distribution. So go to a chi-squared table. Some of them will have the option for 2 tails, and you can just say alpha is 5% and degrees of freedom is 30. Some of them don't have that, they just have, so I'll actually make some space to write this down. They just have chi-squared sub some number. Sub will give you the area to the right, so you would have 0.975 and 0.025. So this is the left critical value. It's got 2.5% to the left, 97.5% to the right. I better put the degrees of freedom on here as well, because those are important. This one has 2.5% to its right. So the lower critical value is 16, 3 decimal places. Let me go get the table. Squared table. So 30 degrees of freedom. Area to the, 16.791. And 2.5% to the right gives me 46.979. So there are the critical values that we need.